speaker. Our next speaker is Mr. Roelf Alberts, who's graduated with an honors degree in business economics. He'll be taking us through technology innovation, cabin theft and vandalism and maintenance, train safety and circulation in the SA railways. Mr. Alberts, you can take the podium. You've got 20 minutes for presentation, and then the 5 minutes for Q&As. Thank you.
Good day, colleagues. Good to see you all. Thank you, Nozipho, for the introduction, and looking forward to the session. It's a privilege to be able to share some information and knowledge with everyone today. I'm going to talk about technology innovation, curbing theft and vandalism, and maintaining train safety and circulation in the South African railways, presented by Gear Roel, who's one of the leaders in train safety control solutions throughout Africa. Frasha, who's a pioneer and a world leader in wheel sensors and axle counters, and Sensonic, who's a pioneer in tracking technologies using what we call distributed acoustic sensing, also revolutionizing railway operations. If we look at innovation provides solutions of a lot of challenges that's currently experienced in the railway industry in South Africa. This is a business day article. In just 14 days, Transit Freight Rail has experienced 152 incidents of cable theft, and more than 40 kilometers of cable has been stolen. Transit is a main artery of the South African economy. When these incidents happen, theft and vandalism has literally brought the railway industry in South Africa to its knees. It's very important that when theft and vandalism happens, the first thing that happens is that train circulation is impacted, train tracking, there's decongestion, there's delays, there's a loss of capacity, and it's got a huge impact on the overall flow of cargo through the economy itself. So the question we have is, what technologies and innovative technologies can we use to apply to, first of all, address this theft and vandalism, while we are able to still detect theft and vandalism, maintain train safety and operations, so that we still continue, even if the theft and vandalism of the signal cable has happened, that we can still maintain the train circulation on a continuous basis, and also what technologies can we deploy that gives us a full view of all the condition of the track itself, on a continuous basis, 24/7, network-wide. And the technology that I'm going to present today as part of innovation is fiber optic sensing. It's an emerging technology. It's very mature, and it provides a huge amount of promises to address these huge challenges that's currently experienced in the railway industry. If we just look at what's currently happening, so the way we operate is we take a fiber optic line, a normal fiber optic line. We install it in the rail track itself, and it's normally a lot of railways already have a telecoms fiber. So we from a Sensonic point of view, we then turn this fiber optic cable that's already installed, and we use that. And what that gives us when we put this fiber optic line in the ground, first of all, fiber is a low value asset, so it's not stolen, it's got no value, you can't resell it, you can't resell it. And what it gives us, it literally gives us eyes and ears on every couple of meters in the track itself for a distance of up to 80 kilometers. We don't install any other components on the track. We don't need any other components on the train itself. And what we do is we create all this information that's being generated through that fiber optic cable along the track. We create a vibration digital twin to analyze this huge amount and volume of data, and turn that into sensible information that the railways can use to their advantage. If we dig into that to just understand how it works, first of all, we shine a laser through the fiber optic cable 2,000 times a minute. Backscatter is then generated of the impurities in the cable itself, and that provides a normal ground truth of the acoustic profile of the entire railway. As soon as we get a vibration event happening, this vibration event creates what we call the altered backscatter. And it's the altered backscatter that we classify as very distinct events. And that can be a security incident, train tracking, or train condition monitoring. And all these vibrations are the things that we use as a feedback mechanism and turn this into information to determine what is exactly happening on the track at that point in time. The way we install the fiber optic is very simple. It's a very quick, cost-effective solution to install. We don't have to go deep. We literally install it between 1 and 5 meters on the track itself, 250 mils deep and around 1 meter deep. It's not armored, it's not protected, so it's literally installed in close proximity to the track. This is the recommended framework for installation, and because it's not deep or armored or buried, it's very easy to install. In fact, a lot of railways already have fiber optic that they use on the track itself. When we go in and we look at so what do we get from all these applications that we can use? First of all, the fiber optic allows us through the feedback of that of the acoustic profile that's been generated. First of all, we are able to do train tracking, so we can do position, speed, we can do direction, ETA, so we know exactly where the train is because it's tracking, providing feedback on every meter on the track itself. On the security side, we can detect unauthorized entry on the track. For example, if there's cable theft or digging happening on the track, we can immediately identify that event. And also then we've got condition monitoring, like critical rail defects happening on the track. If there's work crews working, if there's a fiber break, or if we look at further condition monitoring, for example, that would be flat wheels or rail break on the track itself. If we delve a little bit deeper into this, you will see that we use the fiber optic cable as a sensor. So that's our sensor that we use, and we lay that on every little meter of the track. Through that, we generate train tracking, we do condition monitoring and security monitoring. All this information is fed back, and this huge amount of data is then put into this Sensonic Smart Operations and Management open access platform. It's a cloud-based solution. What we are also able to do is, if there's other data being generated on the track already, for example, from signaling systems, maintenance systems, other sensors on the network, other infrastructure sensors, we are able to also pull that data into the network itself, and we are able to then use that. And all this data is then being analyzed applying big data management, artificial intelligence, and deep learning. So if we start and we drill down into the train tracking side, now when a cable theft or digging happens, the first thing we need to know is that we are able to track certain information. This is one of the engineer's dashboard. And what the engineer's dashboard, it provides information related to the different acoustics events along the rail track itself. In these graphs are also known as waterfall diagrams. The x-axis represents a kilometer point along the rail network, and the y-axis represents the time. And as you can see, the top view, as all this information, a huge amount of data is now generated by the fiber optic sensing, there's a lot of noise coming through the system. And then the artificial intelligence starts applying and clears up the noise because it tracks each little event and declassifies what's not relevant. And when you look at the bottom, you can see that we've got a full picture of exactly two trains in a section. You can see that the trains are moving, and there's no other clutter or information related to this information. If we go into the train tracking side, this is the display unit. You can see that these trains are moving. It gives position, speed, intervals, and so based on that, the display also will notify operators of any irregular acoustic events that's happening on the rail track. So we will know which track the train is on, if there's any digging or unauthorized entries on the track itself, work crews. This will pop up as alarms from the DAS algorithms that the operators can immediately see, and when there's an event happening, send out maintenance crews to investigate further. If we look at the train tracking side, the operation itself, it's based on machine learning. It requires no tuning phase because we've already done a lot of evolution over the past 10 years in terms of looking at the data, analyzing the algorithms. And it's got a lot of additional functionalities that we can use in terms of track selectivity, axle patterns. The quality is smaller than 8-meter accuracy. It's 95% of the track, and we can also distinguish between tracks. So either left or right track, know exactly where the train is. We also integrate this with customers' unique systems and applications. So, for example, if there's unique train IDs or applications, we can also integrate that fully back into the system itself. If we go further and we look at the train tracker itself, the different use cases, the train tracker algorithm is very mature and it can provide the users with extremely reliable information pertaining to train location, speeds, or warning systems of maintenance crews. And what we say is, in the event that there's cable theft happening, then in terms of let's say the signal cables are stolen, the signal system is down, in conjunction with our train tracking and other safe rail operating procedures, based on non-vital fallback systems, we can then still maintain the train circulation and make sure that that we continue to move the trains and don't lose that capacity in terms of that. And still applying the traffic management, we can also use a lot of other applications for that as well in terms of what we do. Another function that we get, except the train tracking, as I've mentioned, is continued track monitoring. And this is the condition monitoring that we are using for this. So from a condition monitoring point of view, we are, you can see there's a track signature being identified. The track signature each track has got a blueprint, it's got a fingerprint of its own, it's got a full track signature that's being generated. And the easiest way to explain this is that the train is literally the scanner. So the trains are vibration monsters. They are generating a huge amount of vibration on the track itself. And each track, it's got its own unique signal identifiers that's being applied. So in this instance, you can see that as the trains have moved by, there's a deteriorating condition in the track. This deteriorating condition shows you every time the amplitude increases, the track gives us feedback that there's a weak spot in the track that needs to be identified. And this can either be missing clips, broken rail, it can be a flat spot or something in the track itself, or broken sleepers. And as you can see, as the trains go over, the track gives us feedback around the different areas that need to be used for that. If we go further and we look at the Sensonic, we look at the operation itself, the algorithms have been validated by global partners all over the world. It's literally an automatic setup. There's no critical defects. We've got a good accuracy within 10 meters. And we've been running thousands and thousands of hours of information and data to be able to identify a lot of different track conditions that's happening. So these are example of degradation of the track happening that's leading to rail break. For example, you can see here in October 21, 2020, this is before the rail break happened. This was November. You can see from the waterfall diagram that there's an increase in deterioration in the track happening. And then finally, after the rail break in January 2021, we've identified, and you can see the rail break has happened. So the idea for us is, from Sensonic's point of view, is to identify a rail break before a rail break happens, send out maintenance crews, and make sure that things are addressed ahead of the time. If we look at the Sensonic use cases, and we go further, that we see that there's non-critical track defects in dark territories, for example, and that we notify train operators to mitigate. So if there's a critical defect in the rail or rail condition happening, for example, if there's we send out maintenance crews, and maintenance crews can address those different areas that need to be addressed on the track itself. The next section that we spoke about is around the security side of things. Security is extremely important and a huge problem for the South African railway industry. For us, it's important to protect the rail infrastructure against theft and vandalism, making sure that that we always have areas that can be covered. So the current mode of action in the railways to protect is to look at hotspots areas, and then only track and monitor those hotspot areas. The fantastic thing about the fiber optic is you can monitor your entire track 24/7, and you don't only have to do hotspots. So you are able to not only focus on high risk areas, you can do your entire track in terms of theft and vandalism and all the technologies that come with this. So because this is a data-driven development, what we do if we look at the machine learning workflow, we've got different use cases. We collect a lot of data through all these applications. Now you can see all these installations all over the world that's currently generating data day by day. We collect that data, we analyze the acoustic characteristics of those things, we optimize and pre-process them, we prepare the data, and then they are generated and deployed. And each railway contributes through machine learning through other railways by getting more applications classified in terms of all the different security events that we've got. So if we just look in Germany, this is an intrusion. There's a video of intrusion and a personnel detection. This track worker is walking on the track itself. You can see here that immediately this event and the waterfall has been classified. It picks it immediately up that this is a person walking on the track. And you can also see he's moving. That event has been classified and provides feedback immediately to the operator that there's someone on the track in terms of a movement that's happening, either authorized or unauthorized, and that needs to be used. If we go further and we look at the personnel detection side, you can see at this water flow diagram, as the person is busy walking on the track itself, this is already classified, and it gives you that icon of a person walking on the track, and it's immediate personnel detection that happens throughout, and all events can be classified and things. The most important thing to also understand about the benefits of machine learning is that that it works on a huge amount of data. So this data needs to all this data needs to be analyzed. It goes through all the different phases of being analyzed using different artificial intelligence, machine learning, and then deep learning to turn that information into sensible information. And the system keeps on learning and be getting smarter over time. It's not open to human interpretation. It's all done via the system, and it's done 24/7 basis. If we look at our treasury of data, I think what's very important to understand is the amount of hours we've got. So it's like having the Tesla for autopilot for trains on the rail track. So the way Tesla works as well, and on the previous speaker with a level crossings, the more data that's collected, the more the railway can benefit from accurate train tracking, rail infrastructure security, and condition monitoring. So it's a data-driven system and machine learning. We've got 10,000 hours, for example, of labeled train traversals. We've got 10 million hours of total data sampled throughout the years. On the train tracking side, it gives you a huge amount of information, different tracks that can be tracked on different sites. You can also look at the security side. For example, 10,000 labeled walking patterns that's already defined in part of the algorithm, 20,000 labeled security breach patterns. So we know if this acoustic profile happens, or they are trying to steal the cable or unauthorized access, it's already been classified in the algorithm. And that's the great thing about the Sensonic platform. It's all about data processing. It's all about artificial intelligence, machine learning, and using all that information to turn that into benefits for all the railways. The important thing is better decisions. The better the information, the better decisions we have, and the better decisions we have, the better we are able to increase capacity, reduce costs, and increase safety. And that's what we provide from a systems point of view. The fiber optic sensing and solution is a very cost-effective solution. It's a solution that can be installed throughout the entire track. It's and because we cover 80 to 100 kilometers per time, it's a very cost-effective solution to detect theft and vandalism, maintain train safety and operations, and track condition monitoring. It's easy installable, and we believe that this is part of the future technologies that will be used throughout the future in terms of assisting the railways to maintain their train circulation. Thank you very much. Happy to take any questions.
Thank you so much, Mr. Alberts. There is a question for you. The alarm tracking system also monitor interference with other components of the system, e.g., rail section, OHTE, etc., for security reasons.
Pardon, Zipo, I just had a short break there in the. Can you just repeat the question for me, please?
Okay. Does the alarm/tracking system also monitor interference with other components of the system? For example, rail section, OHTE, etc., for security reasons?
Yes, it does. So there's different ways we put security in the track itself. We can have fiber in the track. We can put fiber on other perimeters. And another way we operate is we actually wrap some of the fiber around the OHTE cable and then literally track that as well. So it can be any interference on the rail track and the application of that. So especially because OHTE and signal cable are the biggest things that's been vandalized at this point, we can either do that just purely by the fiber optic in the track itself, or if it's more extensive, we even wrap the fiber around the OHTE cable. And that gives us immediate feedback when there's intrusion happening or unauthorized theft and vandalism.
Okay, thank you, sir. Then another question, is Transnet embracing this technology? If not, why not?
So there are discussions happening currently with Transnet. Transnet is very proactive in trying all possible means to find these thugs and vandals who are stealing from all our South Africans all over the world. They are really putting a lot of effort investigating all the possible solutions and scenarios. I mean, this is not the only scenario, but this is something that's being analyzed from a Transnet perspective and a PRASA perspective. And we believe that this is the way to go in terms of the most cost-effective solution to cover a vast network.
Okay. There is also a comment this time around. Someone is saying, nice presentation and thank you.
Thank you. Appreciate
another question for you. How, I think this is, are there any EMC compatibility issues with, okay, how does the passenger wheels differ from freight wheels in terms of design? I think that's one it was meant for the previous speaker. Are there any EMC compatibility issues with other fiber optic cabling
No.
for use on the how train, e.g., is there a possibility to monitor OHTE?
Yes, we can. No EMC influence on that and with other fiber technologies. So remember that the fiber is pure, it's just normal light that's being used. And each track has got its own unique signature. So it doesn't matter if which track or what condition is of the track, each track has got its own unique signature. And we listen to that continuously 24, or the algorithms, not me, but the algorithms listen to that 24/7 and then interprets any events, whether it's OHTE effect. If there's flashovers, for example, on OHTE, we can also pick up flashovers happening on OHTE. And that's through the entire track. So we monitor that on a permanent basis. And that's also one of the algorithms and events that's already been classified and used all over the world, or flashovers, for example, on OHTE.
Okay. Thanks a lot. There's another question. Questions are buzzing from Sibusiso Ntlabati. He's asking, the introduction refers to theft of Transnet OHTE cables. How is the system going to assist with preventing theft when it's installed on the track? The issue in SA is not about locating where theft or alarm is, but preventing theft itself. Electrical control already receives immediate notification alarms when cable is cut. So the question is, how is the system going to assist with preventing theft when it's installed on the track?
So it's a very good question. Thank you. I think currently what happens is when the thugs have access onto the track, and they cut the cable, it's only the operators only get a feedback after the event has basically happened. Okay, so that means the guys have already cut the cable, and it's difficult to determine exactly in which section. Maybe it's a couple of kilometers in terms of where that can happen, and that can be a 20 or 50 or 60 kilometer section. What we do with the fiber optic is we get an early warning events being generated before access is taken place on the rail track itself. And that early warning provides information. Of course, you have to align with some form of armed response, and there's other augmented technologies that will support the entire solution. But you at least get advance warning that there are unauthorized access on the track, and that people are busy, and you know the exact location to the meter of where it is happening. So it's not a guessing game about which section it is, and as we say, you don't only get the security and safety side, you get the condition monitoring and the train tracking. Because once the signaling cable is stolen, your signaling systems are out, but the system still allows you to know where the cable was stolen and still continue with your normal train circulation. And that's the big problem, is your train circulation is severely impacted.
Okay. Thank you a lot, sir. There we end all our questions. Thank you a lot for quite an informative presentation. I will urge all the questions to still be posted on the discussion panel, where Mr. Alberts will further respond to them on the discussion. You are also encouraged to continue with the Q&As on the discussion panel.